As promised in the last video, in this video, we're going to take each of these components, we're going to join things together as much as we can so that then we can efficiently unroll or unfold all of these flat and planar on the XY plane, arrange them in a grid that makes sense, and then assign each one some sort of label and mark each one with a label that can then be inscribed with the laser cutter. Okay, so here we go. Here's our starting point. Here's 100 triangles, 100 triangles. And so one of the things I'm going to do is I'm going to, let's see, figure out how to join things. Oh, B Rep join, there we go. Right, surface, utilities, B Rep join a number of B Reps together. Again, B Reps, just a fancy word for poly surfaces. I'll go ahead and plug these in. So I plugged in 100, 100, 200 things. And if I hold my cursor over it, now I have just 100 things, right? Because each of these triangles share an edge with the other, right? And so this is going to be joined together as an open poly surface. I'll go ahead and turn the previews off for these just so you can see maybe a little better, right? So this is now joined with this for each of these cells. And so that's handy. All right. Now, the other thing I promised is that we're going to figure out a way to unroll these. Now, we all know that there's an unroll command in Rhino. There is no unroll command in Grasshopper out of the box. However, there is a plugin for Grasshopper. It's called Lunchbox Tools. It's right here. And inside Lunchbox Tools, if you have that installed, if you go to Utilities, there's an Unroll Be Rep. Yay, that's exactly what we're going for. Okay, so really quickly, if you go to the course website, there it is, sometime today. All right, there it is, finally, as promised. And you go to Proving Ground, icon that is posted, right? There's a link to Lunchbox Tools. You can download the latest Lunchbox or just look around Proving Ground, which I actually recommend you do when you have a time here. Lunchbox, maybe there's some updates since the last time I linked up to this, but you can go ahead and download it and follow the instructions for how to install if you need to. Okay, but once you do that, install and then restart Rhino, you'll have a new tab, Lunchbox Tools. Oops, I just placed something accidentally. Now that'll give us a chance to use the Unroll Be Rep command. So we're going to look at this. The B Reps to join, right, is one of the first inputs. And then another input is, let's see if I can get my cursor to work a little better. Why won't it run? My mouse must be sticking a bit here. Stupid magic mouse. Here, let me see here. Now, I've already plugged these in, and so you can see all of them have been unrolled at the 0, 0 point. But I'm trying to figure out what it's giving me, and for some reason the right click and the left click is a little stuck on my mouse, which is annoying. Let me just unplug my mouse. Just do it without the mouse. There we go. So now we have 200 surfaces again. What we need to do is make sure that we're joining. We keep everything joined. So go ahead and hit true. No, this thing's just being a little laggy. I think it's because there's 200 unrolled surfaces maybe. I'm not sure why it's taking its time trying to figure this out. Okay, so now we're back to 100 surfaces. Okay, so what that tells me is that as we unroll these, it's not exploding each individual face of each poly surface, right? So we started with 200 surfaces and we joined them together. So they were joined together in pairs. So we only had 100 poly surfaces. Then when this was set to false, then what it did is it exploded those back into 2 surfaces each. So we kept it as true, and that kept things joined. And so that worked out really well. All right, now what we want to do is maybe distribute these along a grid, since they're all just like laid on top of each other over that 0, 0 point. That's not very useful for us. So let's go ahead and place each one on a grid. Okay. What we're going to do is we're going to use the move command. So I'm going to go to transform, Euclidean, and move. And so what we need is the geometry to move, and then the translation vector, right? The sort of position to move it to. So I can plug this in, and now I need 100 translation vectors, or at least 100 locations to move each of these to. Okay, and so what I'm going to do is I'm actually going to create a grid of 100 points. And we're kind of pros at this by now, aren't we? All right. Now, I don't know if you guys have noticed this in the vector tab, there is a grid. There's an actual grid tool, and so we can just say base plane for grid XY, size of grid cells 1, number of grid cells, number of grid cells. So the number of grid cells is going to be all the way back here. Let me just pull this over here so we can see a little better. But right, we're dividing the surface by 10, right? And so that's determining 10 by 10. So let me go ahead and let me go ahead and use that. I'll just actually use 10 here and plug that in for this one and this one. And that way we have 10 for these as well. And what that'll allow us to do is if we ever change this number for the number of divisions in U and in V, then it'll also automatically change here for the number of grid cells that we have. Okay. Yeah, great. You can see them here. And here are the points at the grid corners. Oh, interestingly, it starts at 0 and 10. Oh, so the points we have, so we have 10 cells, right? But that means that we have 11 points. I just want 10 points. Aha. That's interesting, isn't it? So one thing we could do is always take this number and just subtract 1 from it before we plug it in here. Let me try that first. Do math. Do a little subtraction widget. Plug this in for A, subtract 1 from it so I can right-click on the B, set data item, throw in a 1 there. Now I'll plug this in. Now when I look at the points, there's 100 points, which is perfect because we have 100 items. And also the spacing, we might want to change that. So I'll go ahead and put in a little number slider here and change the min-max to something bigger. Okay. Now let me go ahead and move this over to where we need it, because what we're going to do is we're going to use these points as the translation vectors for each of these. One last thing I'm going to do, I'm going to go ahead and disconnect these. I'm going to go ahead and disconnect these for a minute. Disconnect, right click and disconnect. I'm going to go ahead and say flatten everything that's in here and flatten everything that's in here. So I don't want data trees anymore. I want to flatten these out into list. Here's the locations. Here are these. Let's go ahead and spread these out a little bit. Right, by changing the size of our grid cell, right, we change the spacing between each of these. All right, so there's triangle and triangle, right? We can see that there are 2 triangles that are joined together. Oh yeah, each one's different. Look at that. In fact, it's kind of a cool pattern, isn't it? And so from here, we're really close to having some stuff to laser cut, aren't we? So right now what we have is our geometry are basically joined surfaces. The laser cutter doesn't like surfaces. What it likes are curves, vectors that it can follow, lines and curves. So what we probably need to do is get the border or boundaries for each of these, and then also get this little line in between for the scores. Okay. Let me open up the example file. Shell, surface, responsive surface with trusses, shell, surface classification, surface divide. Here we go. Just remember what I used here for it. B-rep edges. Oh, okay. B-rep edges. Interesting. I'll go back to this. So if I go to surface and I look at analysis, there should be something called, B-rep edges. Now, here's the interesting thing. I can plug these in. Okay, so I'm plugging in a bunch of them. And look at this. I get the naked edge curves, which are, basically a naked edge is an edge that, has a surface on, it's an edge of a surface, but then there's like sort of air space afterwards. So this is not a naked edge. This is a shared edge, but this is a naked edge. All four of these are naked edges. They're outside edges, in other words. Then I have the interior edge curves. Oh, isn't that convenient? Okay, and so I'll just pull these out as their own separate widgets so I can select them at a time. We have these. Maybe. And I'll go ahead and flatten them. Don't know why it's saying give me a red error. Oh, it's because I pulled out a surface widget. These are curves. Boy. All right. There we are. So we have those green ones. And then we have these. Okay. Let me turn everything else off now. And let me also, seriously, phone. Let me turn off the grid on this XY plane here. I hate the grid. Why is it always on by default? Okay. And so here are our naked edge curves, i.e. our through cuts. And then here's our interior edge curve, which can be set to a different color on the laser cutter just to score. Okay. And that way you score slightly through material, then it can fold much easier. All right. Yay. And so let me think about one other thing I probably did here. Oh, yeah, that's right. I made little text tags. So what we have to do is we have to generate some text or some sort of way to label these. And then take that text and plug it into this text tag. And we also have to give it a location, each of these text tags location along those surfaces. So just to let you know, that's where we're going with this. One way I can do this is to think about it in terms of each row has a number and each column has a number, right? So each row could be 0 to 1 to 2 to 3 to 4, and then each cell or each column could be 0, 1, 2, 3, 4. Or you could do the alphabet and then a number in one direction, like battleship. So it could be like B12 and C3 or whatever. But it's easier for me just to generate a list of numbers. And in fact, I have them right here. I have a list of points. And so I have 0, 0, 0, 0, 0, 0. Let's see. Let me just do this. I'll flatten these points out. Oh, seriously. Emails are killing me today. Let me pull out these points. And I'll flatten them just so you can see. Yeah. Right. So I have a list of points. Well, those aren't so good. Maybe I'll make one extra grid of points. Anyway, I'm just going to make a grid of points. And for the spacing, I'm just going to disconnect this. I'll set the spacing to 1. Really, all I want from the points is their x and y coordinates. And I just want to use those as numbers. So if you think about this for just a minute, I'll flatten this really quickly. Hopefully. There we are. Now I have a list of points, but if you look at their coordinates, I have 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, all the way to 0, 9, and then 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, all the way to 9, 9. And so I can use that text to sort of differentiate maybe my each of these, right? So I can use those as text tags. And so let me find, I'm going to double click and type in text. Maybe, here we go. All right, text tag, maybe it's this one. No, it probably isn't. Let me double check this. What did I use here? I used the 3D text tag. Okay, that's fair. I can never remember this. It's kind of annoying. Text. Now look for that pesky 3D text tag. There it is at the top. Go ahead and undo that. Okay, and so for the actual location and orientation, right? But then I can also use these points as the text. Okay, so location orientation of tag. Now we need to identify location in each of these surfaces. I don't know. I'm thinking in this case what I'm going to do is just pick like the centroid of each of these surfaces. I mean, I don't know of any other way to do it, to be honest. At least not offhand. I mean, I could try to hide one over here in one of these corners. Yeah, maybe I'll try that. I don't know. We'll see. Let's see. Here are the unrolled pieces. Here they all are moved. Here they are turned to things, non-manifold edge curves. Yeah. I'm not so certain about that. You know, I think what I'm going to do is I'm just going to pick the centroid of each of these for right now. I can go to surface and I can, I think it's surface, let's see. I can find area. All right, so area of a surface or a closed curve. So let's plug these in. Let's see if these are closed. Actually, it doesn't look like they're closed. We should probably join those together. Let's see if we can join curves together. Join curves. Maybe it'd be easier if I just typed it in. Join. Oh, there it was. Join curves. Yay. All right. I'm going to join these bad boys together. Let's see. What are the options? Join curves to join. Preserve direction. Yeah, okay. I'll just plug these in. Now I should have 100 with each. Yes, excellent. All right. Now I can do this to get these areas. And what's interesting about the area widget is not only does it give you the area, it also gives you a centroid of that area. Okay. And so you can see that we're placing this text, but the size of this is pathetic. Let's change the size of this. Plug that in. Lower this way down. I'm not sure what's happening here. Oh, I know. We're getting multiple things. And I think this has to do with our lists. All right. So I'm going to go ahead and right click and disable this for a moment. And I'm going to go ahead and flatten everything that's popping in here. Flatten and flatten. Okay, now I'll go ahead and enable it. All right. Our data trees weren't matching up so well. So now we can also bake these in. Now these aren't curves yet. Once I bake these into Rhino, I can explode them, and then they turn into curves. Okay. I'll go ahead and do that really quickly. So at this point, let me just zoom out here. I'm going to go ahead and bake these curves. Okay. But what I'm going to do first in Rhino is I'm going to go to the layers. I'm going to make some specific layers. 3. So I'm going to say outlines, and I'll call these scoring. Oh, come on. I'll call these labels. And maybe I'll even try to spell it correctly this time. There we go. All right. And so now I can select the correct ones. I can select this and bake these into outlines. I can bake these into, let's see, scoring. And then I can bake these into the labels. All right. I can turn off Grasshopper. I'm going to go ahead and say cell text, select text, and it'll select all those text objects that I just baked in. I'm going to explode them. Now you can see that they're all curves. So that way these can just be quickly scored in, like inscribed. Okay. All right. So that's a starting point. Like I said, we'll go over this again on Monday. But I wanted you guys to look at this. And honestly, the more you can do leading up to fabricating a prototype, the better. But like I said, your assignment between now and Monday is to go through these videos and just perform the steps one by one. But then to take these components, this very simple component that I did, and actually start to change it. These can be your starting point to modify into your own unique component that you're proposing for your own prototype. Okay, and so some of you might be getting this really quickly and just carry forward and even start to unroll things and label things. That's perfect. Some of you might be a little lost. You might have some ideas. Don't be afraid to sketch those ideas out or make a quick drawing of it. That's how these things usually work. You have to sort of work things out before you, sort of develop it and execute it quickly and well in Grasshopper. Okay, so anyway, good luck. Have a great weekend, and I will see you on Monday.